So let's look at some integrals now. Let's evaluate the integral of 3x dx. Well, remember that this 3 here, this is just a scalar. And if you look back at our integration rules, I can pull out that scalar out in front. And now here I have x to the first. I can use my reverse power rule here. This is 3 x squared over 2 plus c. So there is my integral right there. And don't forget to put this plus c on at the end. Let's look at some more. Let's evaluate the following. So a, the integral of 1 over x cubed. So as long as it's not a 1 over x here, I can use my reverse power rule. So the first thing I'm going to do is bring it up to the numerator. This is x to the negative 3. And now do your reverse power rule. X to the negative second over negative 2 plus c. You add 1 to the power. Negative 3 plus 1 is negative 2. Okay, now let's look at another one. Let's look at the integral square root of x dx. Again, we can use our reverse power rule here, but let's rewrite this first. Let's rewrite this as the integral x to the 1/2 power. And now you're going to add 1. If I add 1 to 1/2, it'll become a 3/2 plus c. And then you can simplify this. It'll be, flip up your fraction, 2 over 3 x to the 3/2 plus c. And I do want to mention that here you can check your answer. So you can check your answer by finding the derivative of what you have here. So if I find the derivative, it would be do the power rule, and the derivative of a constant is 0. So I get x to the 1/2, which should match up with what you had here. Okay, so you can check. This tells me that I have the right integral there. All right, and then let's look at another one. The integral of 2 sine x. So remember, you can pull this scalar 2 out in front, and the integral of sine, it's a negative cosine plus c. So it'll be a negative 2 cosine x plus c. And then one more. Let's look at the integral of 3 over x. Again, I can pull that 3 out. 1 over x, looking back at our basic integral rules, the integral of that is ln of x plus c. All right, so what we're going to do is we're going to take it up a notch. Those were all kind of simple integrals. They only had one term in them, so let's dial it up a little bit. Let's evaluate the following. A, the integral of x plus 2. So here I have a sum that is appearing here, so I can split this up using my basic integration rules as the integral of x plus the integral of 2. And then for x, you're going to do the reverse power rule here. This will be x squared over 2 plus a constant, so we'll go with c1. And now compute this integral here, the integral of 2 is a constant, so the integral is 2x plus a constant, c2. And then what I could do is I could combine these two constants together, c1 and c2, into just a single constant. Where c is c1 plus c2. So what this means really is that you don't need to have two separate constants here. You can just give a single constant at the end. So let's look at another one of these where I have more than one term. The integral of 3x to the 4th minus 5x squared plus x. So you're going to do your reverse power rule, right, and work term by term. So start with 3x to the 4th. That'll be 3x, add 1 to the 5th over 5. Then move on to your next term, 5x squared, 5x cubed over 3. And then x squared over 2. And then you can just write a single constant now, plus c at the end. And there is my integral.